on to 8.6. And we are factoring trinomials where a does not equal 1. All right, so here are our steps. Step number 1. Undistribute the greatest common factor. Step number 2, you're going to draw your x. Step number 3, you're going to fill in the x. Remember, it is C times A goes on top and B goes on the bottom. Step number 4, solve the x. So you fill in your sides. Step number 5, if A equals 1, write your factors. This is exactly what we did yesterday. If A does not equal 1, draw a box. Step number 6, we're going to fill in the box. So here's how we fill it in. We have our box. The first spot is the ax squared term. The last spot is our c term. In our diagonal, it is the sides of the x. Step number 7, undistribute the greatest common factor from each row. Number 8, undistribute the greatest common factor from each column. Number 9, write factors. And number 10, put greatest common factor in front. So really I'm only adding 5 steps, and most of the time I'm not adding step 10. So it's really 6 through 9 that we're worrying about today. But this is super important. You have to do it. You have to be able to do this from now through graduation. And those of you thinking of going to college or whatever, you've got to be able to do this. We use it nonstop from here on out. So we have to be able to do it. Okay? So here we go with example number 1. Let's start off super easy. Example 1. This is all you are doing for everything. 8 through 27. Factor. And we're going to start off with 3x squared plus 23x plus 14. All right, so first we look to see, is there a greatest common factor? There is not. So then we draw our x. Last number times the first number. So 14 times 3 is 40, right? Yeah, 42, right? Middle number, the b term, is 23. I am looking for two numbers that multiply to 42 but add to 23. 21 and 2. Very good. Now, since my leading coefficient or my A is not 1, I draw the box. In the first spot in the box, we take the first term, which is 3x squared. The last spot in the box is the last term, 14. In my diagonal, I take the sides of my x and the variable. So this is going to be 21x, and this one will be 2x. It doesn't matter which one goes where. Now we're going to undistribute out of each row the greatest common factor. So looking at this first row, between 3x squared and 21x, what is the greatest common factor? 3x. I agree. The bottom row, what is the greatest common factor between 2x and 14? 2. All right. Now we're going to do every column. So what's the greatest common factor in 3x squared and 2x? Just an x, right? I can't take a 2 out of 3, so it's just an x that's in common. And what is in common in 21x and 14? 7. Then you can quickly check and make sure you're right by multiplying them back together. 3x times x is 3x squared. 3x times 7, that works. X times 2, that works. 7 times 2, that works. So now we write our factors. We have 3x, and it's a positive 2, so plus 2. And the top one is x, that's a positive 7, so plus 7. If I had a greatest common factor that I took out, I would write it here. All right, so questions before I keep going? No questions? Okay. Let's try another one. Example number 2. Let's factor 2y squared plus 13y plus 6. Again, step number 1, is there a greatest common factor I can take out of the whole thing? Nope. All right, so I draw my x. Last number times the first number goes on top. That is 12. Middle number goes on the bottom. What two numbers multiply to 12 and add to 13? 1 and 12. All right. Now we're at step 5. If a equals 1, we get to write our factors. Is that the case here? No. So we have to draw our box. The first spot in the box is the first term in the trinomial, which is 2y squared. The last spot in the box is the last term in the trinomial, which is 6. My diagonal are the sides of my x. 1y and 12y. Now, I take out the greatest common factor in each row. So in the first row, between 2y squared and 1y, what is the only thing they have in common? 1y. In the bottom row, 12y and 6, what do they have in common? They have a 6. Up and down, we have 2y squared and 12y. We can take out a 2 and a y. Excellent. And what about between 1y and 6? Just 1, exactly. All right, so now we're going to write our factors. I have y, and that's a positive 6, so plus 6. And 2y plus 1. All right, now the next thing we're going to do, we're going to start to add some negative signs in. Okay? If there is a negative right next to the side, you're going to take the negative out. Okay? So only if it's right next to the side or right next to the side up here, you take the negative. Other than that, you don't. Okay, so let's do one like that. Example number 3. How about 8x squared minus 14x plus 3. Is there a greatest common factor? Nope. So I draw my x. What number goes on top? 24. What number goes on the bottom? Negative 14. So what are my sides? If the top number is positive, that means that the signs have to be the same. And if the bottom's negative, that means they're both going to be negative, right?
Negative 12 and negative 2.
There you go. Thank you, Cooper. Negative 12 and negative 2. Did you? Good. All right. So right here, again, I have an 8 in front, so that means I have to draw my box. First term of the trinomial is 8x squared. Last term of the trinomial is 3. My diagonal is going to be a negative 12x and a negative 2x. So, this one's a little bit trickier. What is the greatest common factor in our first row? 4 and an x, right? Going to take our x. In the bottom row, there's a negative right here, so I have to take a negative. And what's in common in 2x and 3? Just a 1, exactly. All right, up and down. What's in common in 8x squared and negative 2x? 2x, good. And what's in common in negative 12x and 3? A 3. Now, there's a negative right here we got to take, so we're going to take a negative 3. If there's a negative right next to the side, we take a negative. So, again, we can check. Negative 3 times negative 1 does give us a positive 3, so it all works. Now we can write our factors. 4x minus 1 and 2x minus 3. Questions, questions, questions. No questions? We're doing okay? You too, Tony? You good? All right. So, we probably should do one where we have to take out the greatest common factor. All right, so let's do that. Example number 4. Now, when you get to 22 through 27, it is factoring, but this is where you start to take out a greatest common factor. So kind of give you a little heads up. All right, so let's say I have something like, how about 9r squared plus 3r minus 30. What number do you see we can take out of the whole thing? 3. Okay. So I'm going to undistribute a 3. If I take a 3 out of my first term, 9 divided by 3 is 3r squared. 3r divided by 3 is just r. And negative 30 divided by 3 is negative 10. All right, we're doing great. Now we draw our x. Last number times the first is negative 30. Middle number is 1. What are my sides this time? You're close. How about positive 6 and negative 5? Right? Okay, so now is my leading coefficient a 1? No, not really, so I have to draw the box. First term in the trinomial is 3r squared. Last term in the trinomial is negative 10. In my diagonal, I'm going to have a 6r and a negative 5r. All right, out of the first row, what can I take out of 3r squared and 6r? 3r. I agree, Marco. Nice job. In the bottom row, what can I take out? Very good, Maddie. A negative 5. Up and down, what can I take out? Just an r. What about 6r and negative 10? Positive 2. All right, so my factors are 3r minus 5 and r plus 2. But this time, we did take out a greatest common factor, so step 10, see this guy right here? He needs to go down in front. and we're done. So it's really not that much more by having a greatest common factor. Do we need another example? You're good? Anybody else need another example? Okay, then let's use the rest of this time so that you guys can get your work done. I know there's a lot of going on outside of school, so I want to give you that opportunity, okay? All right, so we are doing 8 to 27 all because this is really important. I'm going to tell you there should be an X in a box